Welcome back to the GraphGrid tutorial series. I'm Vanna, and today I'll be showing you how to use some basic features of GraphGrid ML. In this tutorial, we'll transform and train graph data in order to make predictions using GraphGrid ML's machine learning workflow. First, we'll create a graph in ONgDB using the iris dataset. Next, we'll properly format our data for ML tasks by using a transformation policy. After transformation, we'll train a model using a training policy. In this step, we'll be using Geequel queries within our policy to define the full ML pipeline management. Last, we'll use our trained model to make predictions using what's called a real-time JSON inference. Before we jump into the tutorial, it's important to have some general knowledge about the machine learning process. Machine learning is about processing available data to find patterns in order to produce an algorithm that makes accurate predictions about new data, which is exactly what we'll be doing in this tutorial using our own labeled datasets. The goal of this tutorial is to transform graph data, including the iris dataset, and train an ML model with its features. These are some ML-related terms that we should know so that we understand how to set up our policies. A model represents an algorithm that has been tuned to give predictive output based on input data. It's sometimes described as a black box. A feature is an individual measurable property, like height or weight. A feature set is all the features that we're interested in. A feature vector is a list of values that are representing a data point that can be trained on. The last term is label or class. This is what we are trying to predict. It's important to understand the machine learning lifecycle. The first stage is transforming data. We'll take our raw graph data and transform it into a format that can be trained on. We'll then take our newly formatted data and train a model with it. We can then evaluate our model's performance based on its predictions. Specifically, it uses Spark's MLlib library to drive feature extraction, training, and inference. Spark's machine learning library is used as a training framework. It includes common learning algorithms like classification, regression, and clustering, as well as common transformers and estimators like one-hot encoding and word-to-vec. At a high level, the library works by building pipelines which the data is pushed through. At each stage in the pipeline, the data is either manipulated or fitted. If you want to know more about how estimators and transformers work, check out the link in the description to our doc site where we give a quick explanation with some examples of equations and linear regression. Now that we've gone over some general machine learning knowledge, we can dive into our case study. The first step is to add our data to a graph. We'll be using the iris dataset to train our model. The iris dataset contains 4 features, which are length and width of sepals and petals of 150 samples of 3 species of iris. Those 3 species are Iris setosa, versicolor, and virginica. We'll be using these measurements to train a model to make predictions about species classifications. So I'm going to copy this Geequel query here on the DocSite tutorial page and paste it into ONgDB. If you want to be following along yourself, the link to this tutorial will be in the description. And if we run a query to return all of our iris nodes, we'll see that 150 have been created, and we have all 3 of our species along with their measurements. Now we'll move on to the data transformation process. This process transforms our graph data into a format that can be used for ML tasks. This is done with a transformation policy. These policies define how to get the data from the graph and then what to do with it. The first section of the transformation policy defines source, which gets the raw graph data through Geequel queries and then specifies the return labels for later use in the policy. The Geequel query in our source definition looks for all iris nodes and then returns their properties. And we're defining all of those properties as variables. The second part of the transformation policy is the assignment section. It defines the Geequel snippets that transform the source data into the format needed for training. The key result of the transformation policy is a definition of the feature set. The resulting output is the creation of a single GraphGrid ML transformer node, which is represented here in orange, along with GraphGrid ML feature nodes that contain the extracted feature vectors, which are represented in green. And so I'm going to copy and paste this command to create our transformation policy. Now that our data is transformed, we can train a model. We'll do this with a training policy, which works similarly to the transformation policy. However, instead of Geequel snippets to transform data, the training policy leverages Spark to build entire machine learning pipelines. These policies have a data frame section that defines how to retrieve data from ONgDB and how to change our ONgDB training data into Spark types. From there, the rest of the policy is defining the pipeline stages, the training pipeline itself, and evaluation for the model. Training policies support name-bound inputs and outputs. Here are parts of the training policy explained. GraphGrid ML leverages Spark transformers and estimators to build pipeline stages. The training pipelines then take some or all of these stages and list them in order so that their inputs and outputs all line up. We'll use this endpoint to train our model that we'll call Iris Prediction Model. We can check our progress so far by heading over to MinIO at port 9000. If we open up the ML bucket, we can see that our models, as well as our training and transformation policies, have been saved. If you click on Model, you can see our ML task, Predict, and you can see our newly trained Iris Prediction Model. Now we can use our trained model to make predictions. For this tutorial, we'll be using a real-time JSON inference. The first thing we have to do is load our model. So we'll use this endpoint and pass in the ML task of Predict and our policy name. Now we can use the real-time JSON inference. We'll use this endpoint to make a prediction about the species of an iris using measures that we'll input data for. You can put anything here for these measurements. These are just random values that we're using for our petal length, width, and then sepal length and width. Based on our input data, our prediction model predicted the species to be Iris setosa. So to quickly recap, in this tutorial we transformed our graph data to a specific format needed for ML tasks like prediction. Then we defined our training pipeline stages and trained a model from that data, which we then used to make a prediction. And that will conclude it for this video. Be sure to look out for more tutorial content on the way. In the meantime, you can head over to the GraphGrid community subreddit. There you can ask questions, discuss the platform, or chat with other members in the GraphGrid Lounge. You can also join our community on Discord to chat live about the platform, or follow us on Twitter to get notifications about new content and platform news. And last but not least, subscribe to us on YouTube. That'll conclude it for this video. Thanks for watching, and happy graphing!